Speed with direction. The speed of an object tells us how fast the object is moving. If the speed is known, one can calculate the distance traveled by the object in a given time intervals. To get the position of the object at the end of the intervals, one needs to know the direction in which the particles has moved. Suppose I tell you that at 10:30 am a ball was placed at the center of a field. A boy pushed the ball along the ground to move it with a uniform speed of 0.5 meter per second. With this information, can you find the location of the ball after 1 minute? You can calculate the distance covered by the ball in 1 minute by that formula. S is equal to Vt and it is equal to 30 meter per second. The ball is 30 meter away from the center, but this does not specify where exactly the ball is. That is 30 centimeter from the center in which the direction. To locate the position of the ball, you need to know the direction in which the ball moved with a speed of 0.5 meter per second. So what is velocity? It is a physical quantity that gives both speed and direction of the motion of the body, and the velocity is defined as the displacement produced per unit time. It is also defined as the speed of a body in a given direction. That is V is equal to, that means velocity is equal to displacement by time. If S is the distance traveled by a body in a given direction and T is the time taken to travel that distance, then the velocity V is given by V is equal to S upon T, and the SI unit of velocity is same as that speed, meter per second. Velocity is a vector quantity because its description requires both magnitude and direction. Then the next one is that average velocity. When the velocity of a body changes at a non-uniform rates, its average velocity is defined as the net displacement covered divided by the total time taken. When the velocity of a body changes at a uniform rate, then the average velocity is given by the arithmetic mean of that initial velocity and final velocity for a given period of time. That is, average velocity is equal to initial velocity plus final velocity divided by 2. If u is the initial velocity and v is the final velocity, then the average velocity v average is equal to u plus v upon t. Uniform motion and non-uniform motion. A body is said to be in uniform motion if it travels equal distance in equal intervals of time. A body is said to have non-uniform motion if it travels unequal distance in equal intervals of time. For example, consider a car moves from one position to another position about 16 meter distance within time t 8 seconds. Here the car starts from 0 and after 2 seconds it reaches position A covering a distance of 4 meter from the origin as shown. In next 2 seconds it reaches position B covering a distance of 8 meters from origin, and in next 2 seconds it reaches C covering a distance of 12 meters from origin, and in next 2 seconds it reaches D covering a distance of 16 meters from origin. In this case, the car covers a total distance of 60 meters in 8 seconds with equal intervals of 2 seconds. It means that the distance covered by the car is directly proportional to the time. From the illustration, we can conclude that the car had traveled equal distance in equal intervals of time. So, this type of motion is known as uniform motion. Another examples. Consider a car moves from one position to another position about 60 meter distance within time t 8 seconds. Here the car starts from O and after 2 seconds it reaches position A covering a distance of 2 meters from the origin as shown. It reaches position B covering a distance of 8 meters from origin. In next 2 seconds it reaches C covering a distance of 10 meters from origin, and in next 2 seconds it reaches D covering a distance of 16 meters from origin. In this case, the car covers a distance of 60 meters in each 2-second intervals. From this illustration, we can conclude that the car had traveled unequal distance in equal intervals of time. So this type of motion is known as non-uniform motion. Motion along a straight line. Everything in our world moves. Even stationary things such as your house move in relation to the sun or to other stars. The motion may be purely vertical, that of a falling stone, purely horizontal, that of a car on a level highway, or slanted, that of an aeroplane rising at an angle from a runway, but it must be a straight line. When we try to locate an object in physics, we will usually relate it to some sort of reference point. The point is usually the origin, the 0 point of an axis x, y, or z. Furthermore, we provide a numeric representation for an object's location by placing it either in the positive direction or negative direction in relation to that reference point. For example, let's put a particle at x is equal to 0 meter. The particle would then be located at 10 meters from the origin on the x-axis. As you may have noticed, position is marked by some units of length. The typical unit we will use is meters. Here the distance covered by the object is 10 meters. To describe distance, we need to specify only the numerical values and not the direction of motion. The numerical value of physical quantity is its magnitude. The difference between an object's starting position and the final position after it moves is known as displacement. Speed. What is the difference between two identical objects traveling at different speed? Nearly everyone knows that the one moving faster or the one with a greater speed will go further than the one moving slower in the same amount of time. Whatever speed is, it involves both distance and time. Faster means either farther, greater distance, or sooner, less time. Doubling one's speed would mean doubling one's distance traveled in a given amount of time. Doubling one's speed would also mean halving the time required to travel a given distance. The rate of motion of an object can be measured by finding out the distance travelled by the object in unit time. The SI unit of speed is meter per second. In most cases, object will be in non-uniform motion. Therefore, we describe the rate of motion of such object in terms of their average speed. Average speed is equal to total distance travelled by total time taken. Speed with direction. Velocity is speed in a given direction. Speed describes only how fast an object is moving, whereas velocity gives both speed and the direction of the object's motion. To have a constant velocity, an object must have a constant speed and motion in a constant direction. It is calculated in the same way as we calculate average speed. It is given by the arithmetic mean of initial velocity and the final velocity for a given period of time. Average velocity, which is equal to initial velocity plus final velocity upon 2. Mathematically, V average is equal to U plus V upon 2, whereas V average is the average velocity, U is the initial velocity, and V is the final velocity of the object. Speed and velocity have the same unit, that is meter per second.